Now take a peek at this example. Here I have both x squared and y squared having non-zero coefficients. So given that their coefficients have the same sign, this is going to represent an ellipse or a circle or a degenerate conic section. I'm not going to look at degenerate conic sections, and I'm not going to look at circles. You took care of all that stuff back in 9th grade high school algebra. So that being the case, I'm going to make the assumption it's ellipse. Otherwise, I wouldn't give you such an example. So let me go ahead and co-locate all the terms involved in the variable x, all the terms involved in the variable y, and slough off in the constant term. Now I can't complete the square on x because the leading coefficient is not clean, it's not 1. So I'll factor out an 8. Now I'll complete the square on x. Uh-oh. Before I complete the square on x, can I factor correctly? Now completing the square on x, I'll add the square of half the coefficient of x. All right, everybody, this is not working. Technically speaking, that's too light. My blue pen's fading. How if I do this instead in black? I'll triply underline it. It's not legal, so I'll compensate by adding the same thing to the other side. Complete the square of y and compensate. Rewriting this trinomial as its equivalent of perfect binomial square. Here too. Collect constants and force that to be 1 by dividing both sides by 4. I do believe this is in the standard form for the equation of ellipse. Now, clearly A is 2, B is the square root of 1/2. I'll always consider A and B being positive. I'll even consider C to be positive. So that being the case, to actually dive in and sketch this graph, here's the x-axis. Here's the y-axis. Now the center is located at h comma k, which is 1 comma negative 2. Now a is equal to 2, and by the way, since a is over here, which is 2 squared, this really is a squared. So the a squared or the a being bigger than the b squared, which is 1/2 or the b, then I'm elongated more in the vertical direction. And so my vertices are going to be located 2 units above and below the center. The co-vertices are going to be located b units to the left and to the right of the vertex, where b is 1 over root 2. To the best of my clumsy ability, I will connect the vertices or co-vertices with an ellipse elongated more in the vertical direction. And I guess the only thing I'm missing are the foci located at maybe F1 and F2. Now, recall that c squared is equal to a squared minus b squared. A squared is the larger of the 2. So that c value gives the location of the foci by adding this or subtracting it from the y coordinate of the vertex, because I'm elongated vertically. I add or subtract from the x coordinate of the center. I don't know if I said that correctly. Can I scratch that? The foci are located that many units above and below the center, because I'm elongated vertically. So I elongated vertically, that I would add or subtract that from the x coordinate of the center, not the vertex. Anyway, adding that to the y coordinate of the center. Here's the location of one of the foci. Here's the location of the focal point. I suppose that's clear enough. I may not have unitized my axis, but at least I clearly labeled the points of interest, namely the vertices, co-vertices, and foci.